Hey everybody, Happy New Year. By the time you see this video and it posts, it will be 2022. Some of you who follow the channel and were following the Yerf dog go-kart project were probably wondering what was going on. How come we haven't seen that in a while? Well, the truth of the matter is that a couple of months back, after we finished kind of straightening out the wiring and had it running really good, my son Aidan and a friend were driving in it together. As you know, it's a two-seater, and they were having fun whipping around the field, and then the rear wheel fell off. And what ended up happening was, the reason why it fell off was because the rear axle snapped right here. So the splined area that goes in the hub, right where that ends, and where the diameter of the first step in diameter, well, technically the smallest diameter is where the threads are, then it increases in diameter where the splines are, then it increases in diameter here, then it increases again here where the bearing sits, and then it increases again here, and stays this diameter throughout the whole middle section before it steps down to the bearing here and basically reverses, right? So I can actually see a twist in this. So this looks almost like it twisted slightly before it snapped. Apparently, from what I'm reading online now, it's not an uncommon thing for this failure to happen on these stock axles. There is a relatively cheap Chinesium axle that is sold online for around 150 bucks. That is supposedly like a direct replacement for this. The problem is it appears to be out of stock everywhere. So it's another one of those, shipping problems where we're not getting supply or whatever. There's a company called, I believe, BDX, which makes an aftermarket beefed up version of this axle, which that would be really nice. The problem with that is it's 300 bucks, and you have to buy the new hubs because the people at BDX realized that, this is a weak point for this thing. So what they did is the axle's actually larger in diameter, and this section right here is larger in diameter. So it won't fit into the original hubs that are on there. So you're going to have to replace the hubs to do that. So now you're talking, it gets expensive real fast. My son was thinking about bringing it to his Votech school and asking one of his friends in the machine shop to make another one of these. But we hadn't gotten down to the nitty-gritty of, taking all the measurements to make sure they make this thing exactly the way this is made and how that would all work out. To make matters worse, the way that this is constructed, this hub and this hub, which one is for the chain sprocket and the other one is for the brake disc, these two hubs are welded to this sleeve, and then this sleeve is slid over the axle and then welded in place. So if they made this axle, then we'd have to make up another one of these, slide it over and weld it in place just like this one. Maybe we could cut this axle off and bore out the remaining axle that's left behind, but I'm not sure about how successful we would be at doing that perfectly straight. It might actually just be easier to make a whole new one of these. There are aftermarket axles that can be had for as little as like 50 bucks. What you get there, though, is you get a very random type of axle that you're going to have to retrofit to your situation. Most of those axles do not have spline shafts on the end because that's extra manufacturing cost there that they try and avoid by having just a smooth shaft at the end with a keyway. And then the hubs, you would buy hubs that would have keyways in them, and you would just use key stock to lock the hubs to the shaft for rotation, and then still have a nut on the end, threaded area on the end with a nut to keep the wheel from falling off. So I've been thinking about this, and I've been thinking, maybe I could make a couple of extensions that could slide over this section of the shaft, end up getting welded in position, and, replace this broken end. If I'm going to do that, I'm going to want to do both ends, because the same weak point that snapped here could potentially snap on that end. The problem with that is this diameter right here is where this passes through the bearings. And the way the bearings work on this thing, it's almost like a clamshell type of design to hold the bearings in place on the buggy. But I noticed that a lot of these aftermarket setups that I've seen, where you get the whole shaft and new hubs and everything, they come with pillow block type of bearing holders. So obviously, excuse me. So obviously, we could change that if we had to. So I'm thinking, make sleeves that go over here, buy larger bearings to accommodate the larger diameter of the sleeves that are going to go over here, and try and reuse the rest of this shaft, because this is pretty thick here. So the overall length of the shaft is about 38 inches. I'm sure it's actually metric. The shaft at its thickest point is about 1.18 inches, 30 millimeters, almost dead on, so yeah, it's metric. Steps down to about 24.6 millimeters here, but where it failed is only 20 millimeters. So what's my plan? My plan is I'm going to make a sleeve that will slide over this thicker section here. I can't reuse this bearing surface and use the old bearing sizes, because the problem is the way that this goes in. If once I put this sleeve on here and it's welded on there, I can't pass this through the bearing. So whatever the OD is of the sleeve that I put on here is going to be the ID of the new bearings. I've obviously got to make the wall thickness of this sleeved area thick enough to be strong, so it's going to be pretty large. Then the part that sticks out here that's going to go into the new hubs, I'm not going to want to have to deal with making these splines. I mean, I could do it on the milling machine. I do have enough tooling and everything and jigs to be able to actually do this job, but it's going to turn into a real long poop show. So I don't really want to get that involved. So I'm going to just make this a straight shank, and I'm going to cut a keyway in it. Cheat, essentially. And then I will have a section on the end here that will be threaded to accept a nut to hold the wheel on. Other than being able to reuse these castle nuts, that would be the only benefit to making that threaded area on the end the same size as it is now. Since I'm already going to make this section larger in diameter, I might as well make this larger in diameter and just get new nuts. So to start with, I just got to figure out how long I want to make this and how thick I want to make this. If this ends up being a little longer further out here, that just pushes the rear wheels out a little bit further, which might give it a little more stability, so it wouldn't be a horrible thing. But I'm probably going to try and keep it about the same as it is.
was having a little bit of trouble with this thing, and then I decided to check, and I'm glad I did. This shaft has a slight taper to it. There's actually, I don't know what the heck's going on here. There's actually a transition point right here. That almost looks like a ground off weld or something. I don't know what's going on there. There's a definite step here. We know about that. This is where the bearing is supposed to ride. So there's a shoulder right here. That I know about. But then right here, there's something. So I thought maybe it was like, okay, there's a change in diameter from here to here. But it turns out, even from here to here, there's already a little bit of a change. So the whole thing's got a little bit of a taper to it. A little more play in there than I would like, but once this is welded in place, I think it'll be okay. Fun fact, my over 100-year-old lathe has built-in automatic taper turning. And no, I'm not talking about the tapering attachment you may have spotted on the back. I'm talking about, it's just that old. The spindle bearings, I've messed with them on more than one occasion, and I've never been really good at getting the clearance correct. So what you get is when you're cutting, the cutting pressure actually can move the whole spindle a little bit and create a taper situation. At least I think that's what I figured was causing it in the end. And then I just decided that I'm going to live with it. The thing's over 100 years old, you know. So, anywho. Well, that's one of the things about carbide that isn't so great. I accidentally, I didn't move the cutter out of the way when I was setting my carriage stop, and ended up moving the carriage forward and ramming this into the face over here. And I didn't hit it very hard, but because carbide is brittle, I busted the tip off there. And I didn't notice it at first because I didn't have my glasses on, but, well, all of a sudden it was cutting really poorly. Oh, it turns out I was out of inserts for that boring bar, so I just switched to another one, and it's a lot shorter, but I'm only boring this counter bore at the end here. So I just made the final pass, and I'm pretty satisfied with this. I'm not going to push it all the way in. It wouldn't take much tapping. It's a press fit, so that's what I'm going to leave it as. I just don't want to push it all the way in right now because then I'll have trouble getting it out. But I will, on final assembly, I'll be able to press that in there and then weld it up. And that should be a really good, strong connection. So now I need to turn my attention on the other end of this, which is going to be the new shaft that's going to have a keyway in it for the hub. Now, the dimension of that, how large of a diameter I'm going to make that, really is going to depend on whether or not I can modify the existing hubs to accept this, which would save me a lot of time. If I could just remove the splines from the inside of that existing hub and slot a keyway in it, that would be nice.